Today we're doing the fourth set of exponential notes, and this is the final set in the chapter. So the first example says Deshaun is in his 5th year of employment as a patrol officer for the Metro Police. His salary for the first year of employment was $43,000. Each year after his first, his salary increased by 4% of his salary the previous year. Write an exponential equation S of t that models Deshaun's salary for t years. So, similar to the equations that we did earlier in the week, we're going to be kind of thinking about this idea that the 43,000 is our principal. It's what we're starting with. The 0.04 is our interest rate. And what we don't know is the time. We're trying to write like a general equation here. So we would always start with our principal. And then going back to those basic formulas, there's always 1 plus the interest rate. So I know this is going to be a base of 1.04. And the only thing that's different is our t value. So they don't get the raise. He doesn't get the raise until he's put in 1 full year of work. So we have to raise it to the t minus 1 power. Because I need to remove that first year before I can start getting my, so we can start getting that raise. So for letter B, we would plug in 5, and that's how we would calculate this answer. Now, obviously, in class, we're going to be using a calculator, which would make this a lot easier. You can do this on your phone. It's just a little bit more tedious to do. So I would have 43,000 times 1.04, and because I have it to the 5 minus 1, I'm technically raising it to the 4th power. So if you're on your phone, you would do 1.04 raised to the 4th power times 43,000. Or, like I said, on a calculator. So, when we do that, we get $50,304. So letter C says, what is the sum of his salary over the first 5 years? So what we have to go through is kind of calculate is each year, and then we would add them up. So we know the first year he made $43,000. It tells us that in the problem. In year 2, he made $44,720. And again, you're just plugging in these values and figuring out what you get after you plug it in. In the 3rd year, made $46,509. In the 4th year, $48,369. And the 5th year we have listed above in letter B. So what we would do is add all of these values up, and he makes approximately $232,902 in 5 years. And again, we get that by adding all those values together. Now, letter D is a problem I think is very poorly written. We're not going to worry about that one, so we're going to just cross letter D out, and that's going to go for the same in that next practice problem at the bottom of your page, and also for the homework that goes with this chapter. So go ahead and pause the video, and I would like you to try the example at the bottom. On the next page, it says, when changing the exponent, you need to change the, and you go ahead and fill in base at the top of the page. So it's important that when we're doing these problems and we're changing the exponent to something, I need to change the base accordingly, because I'm not trying to change the value of this altogether. I'm trying to just rewrite it. So notice the directions say change each exponent from x to 2x, round to 3 decimals. So a good way to go about these problems is to kind of separate this and say this is 2 to the 1st power raised to the x power. So we know that this is true. I didn't really change anything about the problem. I just separated the fact that I technically have to the 1st power raised to the x power. And the directions want us to change my exponent from x to 2x. So that means I'd have to multiply this outside exponent by 2. However, because you are completely randomly adding this 2 into the problem, I need to keep things balanced. So I kind of want to do like the opposite of the 2. So because I raised the exponent to 2, I need to raise this inside exponent to a half. So the way we would type this on our calculators is I'd have 2 raised, so 2 raised to the 1/2 power, and it's very important that the 1/2 power is put in parentheses. If you're using it on a phone, I would say 2 raised to the 0.5. So this becomes 1.414, and now instead of raised to the x power, it's raised to the 2x power. And again, once you get the hang of this, it becomes very repetitive. So here I have 1/2 raised to the first, raised to the x. So if I am raising this, timesing this by 2, that means I have to raise this to the reciprocal of 2, which is a half. So when you type a half raised to a half in the calculator, putting both in parentheses, you get 0.707 raised to the 2x power. And the last one that we have is letter C. And notice that 6 is kind of like the idea of a principal. It just kind of hangs out front and nothing's going to happen to it. So I'm timesing this by 2, which means I raise this to the half. So the 6 stays as is. And when I raise 5 to the 1/2 power, I get 2.236 raised to the 2x. And that's really all there is to it. So whatever you raise the outside to, you raise the inside to the reciprocal of that. So pause the video and I'd like you to try the next section. Notice that the directions have changed. It now says change x to be 3x. So it's going to be the same idea, it's just the value is going to be a little different. When you're ready, hit play. So in the next example, it says during a 1-week period, the population of bacteria grew according to the model P equals P times 3.57 raised to the T, where P is the population, little p is the initial population, and the T is the time in weeks. Write an equation that can be used to model the approximate daily growth rate. So key thing here to notice is that they are saying T is in terms of weeks, and I want to change weeks into days. So we know 1 week is equal to 7 days. So I need to just kind of take this equation and apply this idea. So I have the P equals P 3.57 raised to the T. So if I want my time to now be in terms of days, I'm going to multiply this outside exponent by 7, which means I need to raise this inside exponent to the 1/7 power. So by doing that, the equation changes to 1.199 raised to the 7t power. And that is it. So, like I said, these problems are not extremely difficult. It becomes very repetitive once you get the hang of it. So we're going to do 2 more problems. I'm just going to run through one at the bottom of the page because, like I said, it becomes redundant. So the directions say change the exponent from x over 2 to x. So in order to make that happen, I'm going to multiply this outside by 2, which again means I raise this to the 1/2 power. So 2 to the 1/2 power is 1.414. And in my exponents, x over 2 times the 2 over 1, the 2's are going to cancel, and I'd be left with raising it to the x power. So the idea is the same for that next section at the bottom of the page. So just finish the B and C at the bottom of the page. On the next page, you can cross that practice section off at the top of the page. Again, very redundant. We don't need to keep doing the same problems over and over again. But there is one last example I would like to go over, and that is on the last page. It says a scientist places 8.7 grams of radioactive element in a dish. The half-life of the element is 2 days. After t days, the number of grams of the element remaining in the dish is given by the function r of t equals 8.7 times 1/2 raised to the t over 2. Letter A says rewrite the equation so the exponent is t instead of t over 2. So we know that we are going to be taking this equation and this 1/2 right here, I'm going to be multiplying it outside by 2, which means I'm raising the inside to 1/2. So my equation will become 8.7 times 0.707 raised to the t power. So that's all they want in letter A. Letter B says, by what percent is the radioactivity going down by each day? So I'm going to take my decimal on the inside, I'm going to subtract 1 from it. So when I do that, I get 0.293. And if I want to turn this to a percent, I times it by 100. So this means it's going down by 29.3% each day. So again, go ahead and pause, or you can stop the video at this point and try that last one at the bottom of the page.